Reciprocity theorem concept and solved example. So in this circuit at point A we have a voltage source and at point B we have an emitter which measures this current. So reciprocity theorem says that if we swap this voltage source from point A to B and this emitter from point B to A like in this circuit, then the current which will flow through the source branch will be same as that of the current which was earlier flowing through the response branch. One important point, while swapping the voltage source, the polarity of voltage source is such that the current flow due to this voltage source will be same as that of the direction of current which was earlier flowing through the response branch. There are few conditions for reciprocity theorem to hold. First, the circuit should be linear and bilateral. That means that it should follow the Ohm's law, that is V directly proportional to I, and bilateral means that if the flow of current is changed, then it will not change the voltage current relationship. And finally, there should be only one independent source. Let's solve this numerical to verify reciprocity theorem. So in this, we have swapped the voltage source with emitter and emitter with voltage source like in this, and we have now two circuits. So if the value of this current comes out to be same as that of this current, then the reciprocity theorem is proved. So let's find out the value of this current I. Now these three elements are in series and we know that emitter's internal resistance is 0. So the net resistance is 3 plus 1, that is 4 ohms. We can easily find out this current I by using nodal analysis at this node. Suppose this is the reference node and I dash and I double dash currents are flowing. So at this node, as per KCL, I dash is equal to I double dash plus I. I dash is simply 36 minus V divided by the total resistance, that is 4 plus 2, 6 is equal to I double dash, that is V by 12 plus I, that is V by 4. From here V comes out to be 12 volts and I is simply V by 4, that is 12 by 4, which comes out to be 3 amperes. Let's move on to second circuit. Here the net resistance of this branch will be 6 ohms and this current we need to find out. Suppose this is I dash and this is I double dash. Then we can use nodal analysis to solve this. Suppose the node voltage is V with respect to this ground, then at this point, as per KCL, I dash is equal to I double dash plus I. I dash is simply 36 minus V divided by the total resistance, that is 4, is equal to I double dash, that is V by 12 plus I, which is V by 6. From here V comes out to be 18 volts and I is simply V by 6, that is 18 by 6, which comes out to be 3 amperes. And since these two currents are same, hence the reciprocity theorem is proved.